Definition 12.36. The wrapper. Initialize j equals to 0, wj equals to lj equals to empty set, and for every player I, vi to the 0 equals to 1 and si to the 0 equals to omega. While wj union lj is not equals to all players, we perform the following three procedures. First, let wj plus 1 s to the j plus 1 be assigned with the output of the value of procedure with input v to the j, s to the j, and wj. 2. For all I not in wj plus 1 union lj, I chooses whether to double his value, vi to the j plus 1, which will be assigned as 2 times vi to the j, or to permanently retire vi to the j plus 1 becomes 0. For all others, set vi to the j plus 1 becomes the original value vi to the j. 3. Update lj plus 1 becomes the set I in n such that vi to the j plus 1 equals to 0 and j becomes j plus 1 and reiterate. Outcome, let capital J equals to little j, the total number of iterations. Every I in wj gets si to the j and pays vi to the j. All others lose, get nothing, pay 0. For feasibility, the procedure must maintain that for all I and I prime in wj plus 1, si to the j plus 1 intersect si prime to the j plus 1 equals to the empty set. We need to analyze the strategic choices of the players and the approximation laws relative to the procedure. This will be done gradually. We first worry about minimizing the number of iterations. Definition 12.37. Proper procedure. The procedure is proper if 1. Pair 2. For all I not in wj plus 1 union lj, si to the j plus 1 intersect the union of sl to the j plus 1, where the union is taken among all l in wj plus 1. And such collections of union intersect si to the j plus 1 is not empty. And 2. Shrinking sets. For all I, si to the j plus 1 will be subset or equals to si to the j. In words, the pair-2 property implies that the set of winners that the procedure outputs is maximal, i.e. that any loser that has not retired desires a bundle that intersects some winner's bundle. The shrinking sets property says that a player's new tentative bundle must be a subset of the old tentative bundle. A reasonable player will not increase vi to the j above vi bar, otherwise his utility will be non-positive. This strategic issue is formally discussed below. Assume thus, there will clearly be at most n times log of Vmax iterations, where Vmax equals to the maxima of Vi bar, where the maxima is taken among all index I. With a proper procedure, this bound becomes independent of n. Lemma 12.38. If every player I never increases Vi to the j above Vi bar, then any proper procedure performs at most 2 times log of Vmax plus 1 iterations. Proof. Consider iteration j equals to 2 times log of Vmax plus 1 and some I1 which not in Vj plus 1 union Lj that by contradiction doubles his value. Appear to there exists I2 in Wj plus 1 such that Si1 to the j plus 1 intersect Si2 to the j plus 1 is not empty. By shrinking sets in every j prime, which is less than j, their winning bundles intersect. Hence, at least one of them was not a winner and doubled his value, But then vi1 to the j is greater than or equals to vmax, a contradiction. This affects the approximation guarantee, as shown below, and also implies that the wrapper adds only a polynomial time overhead to the procedure.